Hello everyone, I'm Rafael Frignani for the Federal University of Itajubá, and today I'll present our research title, Interface for Operator Parts Inspector Machine in the Automotive Industry. This presentation is organized into 5 parts, beginning with introduction and a brief contextualization of the problem, followed by the presentation of some works related to the theme. We will then present your methodology for solving the problem, followed by the results, and finish with the conclusions and the suggestions for future work. With the advancement of computer networks and the Internet, factories have been utilizing information and communication technologies to enhance connectivity between people and objects, including devices and machines. Industry 4.0 embodies this connectivity in the industrial environment, connecting systems, machines, and humans. In this context, human-machine interfaces (HMI) play a crucial role in ensuring safety, monitoring, and productivity in industrial environments. Our case study focuses on legacy HMI using an automotive parts inspection machine. This legacy system has obsolete, unstable, expensive, and lacked traceability or security access control. Currently, the inspection machine does not allow the traceability of the inspected parts. The HMI lacks access control and frequently breaks down. The solution is proprietary and the license cost is high. There is a lack of data storage and integration with other systems. The main problem addressed in this study is that deficiencies in the human-machine interface of a parts inspection machines have been compromising its operation and maintenance. We identified that the core of the problem is the HMI of the machine, and the primary motivations to solve it are: the actual HMI was proprietary, high cost, and non-customizable. Legacy HMI is unstable, slow, and complex to operate. The system is prone to random crashes. The correction sometimes requires the system to be reinstalled, which may occasion a lengthy period of machine downtime. Moreover, it lacks support for traceability of inspected parts, solves safety and cybersecurity deficiencies, meet functional business requirements like production reports, develop a low-cost customized solution through collaboration with the main stakeholders involved in the process. The specific objectives of this work is develop and validate a low-cost and personalized HMI using free software, enable secure data storage, traceability, access control, and fewer physical buttons, apply Industry 4.0 concepts to automotive inspection in a student production environment. We consider the hypothesis that the use of free software in the development of the HMI enables the creation of a low-cost solution for the operation and maintenance of a non-auto parts inspection machine. We create a low-cost MHI desktop app with a free software. The architecture uses local and remote database for continuity and data access. The touchscreen replaces physical buttons, ensuring safety and compliance with Brazilian General Data Protection Law. Solution based on client focus, validated through tests and employee feedback. Supervisory control and data acquisition systems, named SCADA, are designed to monitor and control machines and production processes in real time. HMI enables human-machine interaction and communicates to PLC, which collects and acts on the sensor data. Some authors have addressed aspects related to HMI and its impacts. Doninger and collaborators have focused on the engineering of the industrial interface to address the inevitable end of the software life cycle and the associated problems, including maintenance costs and difficulties in meeting new business requirements. Quasin develops a model-oriented HMI framework for generating screens for Android from the system's UML models. Matias presents a solution based on web pages that uses a PLC virtual web service to enhance remote experiments in an industrial laboratory. Adiraki uses a PLC and HMI connected to several machines, which makes data available online to the multi-user system. The study developed has applied nature, employing a qualitative-quantitative approach. The research seeks to develop a HMI based on a free software to operate a parts inspection machine at a multinational company in the automotive sector. We collect user requirements through interviews with stakeholders. The HMI features include an interface on a monitor touchscreen with login and session timeouts for security purposes, screens for path tracking, recipes, and alarms. Displays the active status of machine elements for maintenance purposes. Stakeholders' needs were defined through user histories, which guided the definition of the software's functionalities. We developed the software using an incremental model. On increment 1, HMI PLC communication, which actuation and parent control has made. Increment 2 created database to record uses, measurements, and alarms. Increment 3 added access control, permissions, and input validations. Increment 4 has the system protected by authentications and permissions. The deployment diagram illustrates the system architecture, which consists of sensors used for inspecting parts, a seamless PLC programmed with TIA Portal, S7.NET Plus library for communication between the PLC and the desktop. The interface software was installed on a standard desktop. The data is stored locally and remotely and can be accessed via a browser. Below are some of the screens that were developed. On the left, you can see the login screen, and on the right, the main interface screen. For ergonomic purposes, the dimensions of the buttons follow the literature recommendations. On the main screen, details of the quantities of rejected parts are displayed according to the inspector characteristics, as well as for viewing alarms and alerts. On the pusher screen, it's possible to make fine adjustments to the X table and check the status of its movement actuators. On the recipes management screen, on the right, you can manage recipes with defined specifications for each part. The screen on the left allows you to manage users. There are three user access levels. The operator user has limited access to specific screens for machine operation. The maintenance user has operator access, as well as access to the machine maintenance and fine-tuning screens. The administrator user has all of the previous permissions, plus the ability to create new users. The screen on the right allows you to track the inspected parts individually, whose data can be accessed in real time both locally and remotely. The screen on the left contains the alarm log, which is color-coded: red for safety-related alerts, blue for communication, and yellow for warnings and alerts. The screen on the right displays the PLC's digital inputs and outputs, with green indicating an active status. After the system development, we first opted to test it in a simulated environment for safety purposes. The failures identified in the simulator were resolved, and opportunities for improvement were implemented. The system was then deployed in a real environment where no errors occurred. The average screen refresh times in the real environment were similar to those in the simulated environment. Both are adequate. The interface proved to be fully functional in both environments. The interface usability was validated by 11 agents directly involved in the process. The user stories were carried out with 100% success. The user comments range from a visually straightforward, user-friendly interface, which is preferred by participating actors over Telegaze 1. The solutions developer has a cost of 50% lower than a proprietary solution and does not require user licenses. Machine downtime has been reduced. Data is stored redundantly and can be accessed remotely via computer with a browser. As summary of results, we demonstrated that the new HEARM is more efficient and robust than legacy one. The solution meets all business and functional requirements. This study introduced the concepts and culture of Industry 4.0 into the factory study scenario. The research validated the viability of the using free software to develop low-cost automation solution in the studied environment. Estimated 50% cost reduction compared to a proprietary solution. The HMI proved to be intuitive and easy to use, was preferred by the main stakeholders over the old interface. Finally, the conclusions and the future work. Given the problems of the legacy HMI, this work developed a low-cost applications for creating screens, data persistence, and communication with industrial controllers. The benefits of the new HMI is operates the machine using an intuitive interface that incorporates Industry 4.0 principles, access control, automatic emails in the critical alarms, parts traceability, and maintenance data. Through validation the HMI, it was tested in both real and simulated environments, with approval from users with diverse profiles, ensuring it meets business requirements. The impacts of the solutions is available product reports, integration with corporate systems, and greater agility in maintenance, offering more economical and reliable solutions than proprietary options. As future work, integration with corporate dashboards and mobile app for real-time monitoring by maintenance technicians can be done. Thanks for your attention. Feel free to contact me if you have any questions.